Hey guys, I'm Archana from Edureka and I welcome you to this session on Amazon Elastic Container Service for Kubernetes. But before we get started, just let me know if I'm audible or not. Just say yes or no in the chat window. Okay, I see a lot of yes. Okay then, let's quickly go through today's agenda. We'll begin by looking into what AWS is and why is it so popular. Then we'll jump into what containers are and what containerization is. Moving on, we'll see how to create and manage different containers on Amazon EKS platform. And finally, we'll be launching a simple Nginx application on EKS cluster. So I hope agenda was clear to you guys. Okay then, let's get started. AWS or Amazon Web Services is one of the most popular global cloud computing platforms. Using AWS, users can host and manage variety of services on internet using pay-as-you-go model. What I mean by pay-as-you-go model is users have to just pay for the services that they're utilizing on AWS cloud. And various services that Amazon Web Services offers include basic ones such as compute, storage, database, network, and many more. And cutting-edge services like machine learning, analytics, artificial intelligence, IoT, and many more. Amazon Web Services has been frontrunner in cloud computing race for many years now, and it doesn't seem to be slowing down. Officially, it has about more than 1 million customers across multitude of domains. Why do you think AWS is such a hit? Well, it could be due to many reasons. It could be due to fact that AWS offers scalable, flexible, reliable, and agile environment to its users. Or it could be due to fact that you can get cost effectiveness while using AWS services. But mostly, it is due to broad range of services that AWS offers across multiple domains. One of its most popular and flagship services include compute services. Under compute services, we have Amazon EC2. It's a primary and flexible service that provide you reasonable cloud compute capacity in form of simple EC2 instances. And then we have AWS Lambda. It's a core serverless computing service. Using AWS Lambda, you can easily build and run application and services without even bothering about underlying infrastructure like network and storage. We also have Amazon ECS. Amazon ECS is nothing but Amazon Elastic Container Service. It's one of the highly scalable and highly performance container management service that supports different kind of containers. Using Amazon ECS, you can easily run application on managed cluster of EC2 instances. Apart from these services, you also have other compute services as well. But as for today's session, we'll be mainly concentrating on Amazon ECS. Then let's proceed. So, what are containers? Before we get into what containers are, you need to understand what a virtual machine is. Virtual machine is a software-based application environment that is installed to simulate the underlying hardware. So to put it simply, virtual machine gives you an illusion that you're running multiple computers on hardware when in reality you're just using one. So basically, virtual machines offer you virtualization. If we take a look at a diagram which you can see on the screen, you can see that at the bottom layer you have host machine or host operating system. This host operating system assigns different resources like RAM and CPU to all the virtual machines. So all these virtual machines share the resources that are available to them. And then there is hypervisor. It acts as an agent between all the virtual machines and your host machine. And finally, sitting on top of hypervisor, we have virtual machine. As you can already see, every virtual machine has its own underlying operating system, has its own binaries and libraries, and an application that it services. Now, talking about containers, at their core, they're very similar to virtual machines, except that instead of virtualizing entire computer like we do in virtual machine, we just virtualize the underlying operating system in containers. So in container technology, a single guest operating system on host machine can run many different creative applications. This makes containers much more efficient, fast, and lightweight when compared to virtual machines. So in simple terms, you can think of running a container like running a virtual machine just without the overhead of spinning up entire operating system. So now you know what containers are. But how do you create one? How do you create a container? This is where Docker comes into picture. Currently, Docker is the most popular open source software platform using which you can create, deploy, and manage virtualized application containers on a common operating system. So once you spin up first few containers, you will realize that there's a lot of work to do. Let's say you want to run multiple containers, then you need to figure out how to coordinate and schedule all these containers. You need to figure out how different containers in your application can talk to each other. And you need a way to identify failed containers if there are any. And if you want to know if there are any healthy containers and if there are any failed ones and how to replace them. Well, doing all this task manually is tedious. Luckily, this is where Kubernetes comes into picture. Kubernetes is an open source container orchestration platform using which you can manage your containers. It helps with things like you can run containers across many different machines. You can scale up or down by just adding or removing few containers. You can distribute load among different containers. You can launch new containers if something fails. So these are benefits of using Kubernetes. Now, you can avail all these benefits of Kubernetes on AWS Cloud using Amazon Container Service for Kubernetes. So Amazon Elastic Container Service for Kubernetes is a managed service which allows users to run Kubernetes on AWS Cloud without having to manage underlying Kubernetes control plane. Let's go ahead and take a look at a few other benefits. Like we discussed just now, you don't have to manage any control plane when you're using Amazon EKS service. Amazon EKS runs the Kubernetes management infrastructure across multiple AWS availability zones. So you simply provision worker nodes, you create them, and then connect them to your EKS cluster endpoint. Moving on, infrastructure running on Amazon EKS is secure by default. This is mainly because Amazon EKS sets up secure and encrypted communication channels between your worker nodes and your Kubernetes cluster endpoint. Then applications which are managed by Amazon EKS are fully compatible with those on standard Kubernetes environment. What I mean by that is you can easily migrate any standard Kubernetes application to Amazon EKS without modifying any code. Just like that, you can transfer from standard Kubernetes environment to AWS Cloud. And finally, AWS actively works with Kubernetes community. It also makes contributions to Kubernetes code base that helps AWS EKS users to use other AWS services as well. So I hope now you know what Amazon EKS services and what it does. Now let's go ahead and see how it actually works. Just so you know, we'll be following the same set of steps in the demo part of the session as well. So make a note of them. Okay then, getting started with Amazon Elastic Container Service for Kubernetes is fairly simple. First, you need to create an Amazon EKS cluster. This, you can do it using AWS Management Console or AWS CLI. So once you've created a cluster, you need to create your worker nodes and then add them to the cluster which you created earlier. As for the demo part of the session, we'll be using a CloudFormation template to create and configure worker nodes. So once your cluster is ready and once your worker nodes are there, then you need a tool to access your Kubernetes cluster, right? So this is where you can use Kubectl or KubeFeed or Minikube and many other options. So as for the demo part of the session, we'll be using Kubectl to access Kubernetes cluster. And finally, once the cluster and worker nodes are up and running, you can easily launch your application on Amazon EKS cluster the same way you would do with any other Kubernetes environment. So I hope you have noted down the steps. I hope you have understood what Amazon EKS is and what you do with it. Now let's go ahead and see how to create a cluster and how to create worker nodes and attach them to it and how to launch an application. So I'll be launching a simple Nginx application here. So let's get started with the demo. So guys, this is my AWS Management Console. Before we go ahead and create Amazon EKS cluster, there are certain prerequisites. Firstly, we need to create an IAM role. This is mainly to assign permissions to Kubernetes to control resources on your behalf. Secondly, you need to create a VPC and security groups for your cluster to use. So first let's go ahead and create an IAM role. So I'm going to search for IAM here. Click on IAM. You have roles here. Click on that and click on create role. Since we're assigning permissions to Kubernetes service, so select EKS here and click on next permissions. As you can see, this role basically follows two policies. You have Amazon EKS cluster policy, which mainly assigns permissions to Kubernetes to manage resources on your behalf. Then you have Amazon EKS service policy. This policy assigns permissions to EKS to create and manage necessary resources to operate your EKS cluster. So now once you've chosen the policies, you can click on review here. Let's give role a name. Let's say EKS role. Since every information is right here, I'm going to click on create role. So the role is now created. Now we'll have to create VPC and security groups. This VPC and security groups are nothing but resources that you use on AWS cloud. So I can go ahead and create them using a CloudFormation template. Basically, CloudFormation is a service which allows you to use a single text file to manage all your resources that you're using on AWS cloud. So as you can see, this is my CloudFormation console. And I'm going to click on create stack here. Well, you have an option to create your own template or use a sample one, but I'll be using a new specific URL here. So for that, open Amazon EKS documentation. Click on get started here. Okay, when you scroll down, here's the URL. I'm going to copy it and paste it. Well, if you want to know what template actually is, you can go ahead and click on view in designer here. Basically, it's going to create a VPC and a security group and 3 subnets. Click on next. We'll have to give stack a name. So let's say EKS service. As you can see, this is the VPC block subnet 1, subnet 2 and subnet 3. Click on next. So this page is optional. If you want to assign any additional tags, then you can go ahead and do it. Or if you want to assign any IAM role so that CloudFormation can access your resources on your behalf, then you can go ahead and do that as well. I'm going to leave this page blank and click on next here. So review URL, right, it's right. And then click on create stack here. So as you know, we have used a CloudFormation template here to create VPC and security groups. Well, you can create this on your own as well. You have a service called VPC here. You can go ahead and create VPC using that as well. If you want to know more, then refer to Amazon EKS documentation. It's given properly over there. So bear with me, guys. It's going to take maybe 1 minute. So once we're done with the prerequisites, that's IAM role and VPC, we'll go ahead and create a cluster. So it's created successfully. Now let's go ahead and create a cluster. Before that, click on the stack which you just created. Go for outputs. And maybe you can just copy all this VPC ID, subnet ID and security groups in a editor so you can refer to them easily. Okay, I'm going to paste it over here. Yeah, it should be fine. Let's go back. Now let's go ahead and create EKS cluster. So when you search for EKS, this is the page where you land. Click on next step here. Give a unique name. I'm going to use Nginx cluster. Version, it'll take the default current version. And IAM role, as we know, we created one earlier. That should be this, right? Okay, then VPC. Let me go back and check the ID. It says it ends with CB. That's that. And the subnets which are related to VPC have already been specified here. Then security group as well. This one. So once you're sure that you've given correct details, correct VPC and the subnets and security group, click on create here. So guys, it's gonna take a while for the cluster to get created. So let's go ahead and install some software. Like I said earlier, you need a tool to communicate with Kubernetes cluster. We'll be using Kubectl here. So let me show you how to install it. Go back to EKS documentation part. And if you scroll down, it says install Kubectl here. Let me open it in new tab. So depending on the operating system you're using, you can download it. I'm using Windows, so firstly you need to open your PowerShell. Well, you're using curl command to download the software here. I've already downloaded it. Once you've done that, you need to add this binary to your path. And suppose if you have any directory which is already there in the path, and if you've stored this kubectl.exe file there in that directory, then you know that you don't have to change the path. I've already installed it, so I've created a separate folder called Kubernetes and I've stored kubectl.exe here. So all you have to do is create a new directory like I did. Copy your kubectl.exe binary to the new directory. Then you have to edit your path environment variable. That is, you can click on this PC here and right click on properties, add system settings, environment variables and path. Click on edit here. As you can see, I've already added the path here. So make sure you've made necessary changes in the path. Let me see if the cluster is created. It's still creating. Anyway, in addition to Kubectl, you have to install AWS IAM Authenticator as well. It's basically a tool for using AWS IAM credentials to authenticate a Kubernetes cluster. So let's say you are an admin, you're running a Kubernetes cluster on AWS. So you already need to manage AWS IAM credentials to create and update your cluster. In addition to that, you also need to check if the user is authorized to access your cluster or not. Well, this is a lot of work to do. Instead, you can use AWS IAM Authenticator. This assigns IAM users to some certain role and it determines if a user has access to cluster or not, if you can use or if you can access the cluster or not. So let's see how you can install that. Going back to documentation page, it says to install AWS IAM Authenticator here. Well, again, depending on the operating system you're using, you can just click on the link or you can use curl command on PowerShell to download it. So once you've downloaded, again, you can, for easy access, you can go ahead and store it in the same directory where you've stored your kubectl.exe binary. As you can see, I have it here. So make sure you install Kubectl in AWS IAM Authenticator properly. So since it's taking long, let's go ahead and check if Kubectl and AWS IAM Authenticator are installed properly or not. So let me go to my Kubernetes folder. There, if it's installed properly, then it should give you an output for this command. I'm just checking the client version here. So since it's giving me output, I'm sure that installation was proper. Same for AWS IAM Authenticator as well. You can give help command. Yeah, well, it's working. Both of them are installed properly. So now Let's go back and see if the cluster is created yet. So finally it's created. It usually doesn't take this long, but sometimes it might take. Anyways, now that we've created cluster, we need to make the Kubectl tool which we installed earlier to point to cluster so that we can access the Kubernetes cluster. So let's go back to PowerShell. So we'll be using a command called update kubeconfig. When we use this command, a configuration file will be created by default. If you have created cluster earlier, this config file will be updated. If you haven't, then it will be created. Well, you can configure your tool to point to cluster using AWS CLI, or you can do it using AWS Management Console as well. But I'm using AWS CLI. If you're using AWS CLI, make sure that you've installed the current version of it. Let me check for the version here. And in addition to that, you also make sure that the Python version is above 3 point. Okay, so let's go ahead and use update config command. And I need the name of the cluster. I'm going to copy this and paste it here. It says added new context so and so to config file. Let's go back and check. Localhost and users. I have .cube here. Under that I have config. And when I click on open with, as you can see, a cluster has been added here. So now that the cluster is created, our next step is to create worker nodes. Again, as you know, worker nodes are nothing but EC2 instances. Those are nothing but resources that you use on AWS Cloud. So again, I'm using your CloudFormation template to create this worker nodes. Click on CloudFormation or search for CloudFormation. Click on Create Stack here. Again, I'll be using the URL. Let's go back to EKS documentation, and in the step 3, you have URL. Paste it here. So basically, using this template, we're going to create worker nodes. Again, give your stack a unique name. Let's say Nginx cluster worker nodes. One more important thing, guys, here the cluster name should be exact same as the one which you created earlier. Don't make a mistake, otherwise your worker nodes won't be able to connect to the main cluster. So to avoid making that, let me copy the exact name from EKS console. So I'm going to copy this cluster name and paste it here. Now the security groups are the same ones which we created earlier. So this should be it. Let me just check. And give your entire node a name. Like 1 is the minimum number of instances that your auto-scale group will create, and 3 is the maximum number of instances or worker nodes. Well, like I said, worker nodes are nothing but EC2 instances, so obviously you'll be needing an Amazon machine image. For that, let's go back to documentation part again, and you have AMI here. Well, make sure to check out in which region you are. I'm in North Virginia region, so I'm using the North Virginia region. So I'm copying this ID. And you'll have to give a key name as well. I've already created one. If you haven't, just go to EC2 services and under networks, let me show you that. So under network and security, you have key pair option. You can go ahead and click on create key pair. Once the key is created, you download the file. Once you've done that, you can see your key here. Well, if you want to assign any additional features, you can do so using Bootstrap arguments. And finally, VPC ID here. And Make sure you've selected all the correct subnets. So once you're sure that you've given all the details correctly, click on next option here. Like I said, this page is optional. So if you want to add any tags or assign any IAM role, you can do that here. I'm going to skip this and click on next. Before you go ahead and click on create, just review if you have given correct details like the cluster name and number of nodes, node group, AMI and all that details. And click on this. It says I acknowledge that AWS CloudFormation might create IAM resources on my behalf. And then click on create stack. So guys, it's going to take a while. Till the stack gets created, let's go ahead and take a look at architecture. So guys, as you know, Amazon EKS is a fully managed service where you can deploy, manage, and scale different type of containers using Kubernetes on AWS. And this EKS service runs control plane across multiple availability zones. So as you can see, I have my EKS control plane here in EKS VPC, and on the other side, I have worker nodes running on my VPC. So once the worker nodes are created, we have to configure these worker nodes to connect to EKS cluster. For that, we need to make some network changes. Like we need to ingest ENI, that's nothing but Elastic Network Interface. Basically, it's a component of VPC and is managed by EKS control plane. So if your EKS cluster or Kubernetes cluster wants to interact with EC2 nodes or your worker nodes or applications that are running on this worker nodes, then it'll use this Elastic Network Interface to do so. Similarly, suppose your applications or your EC2 worker nodes want to interact with cluster, then they'll be using network load balancer here. So like I said, the architecture is basically very simple. You have your Kubernetes cluster and you have control plane using which you can control your Kubernetes cluster. You have your kubectl using which you can access your cluster. Then suppose if your cluster wants to communicate to worker nodes, it will be using Elastic Network Interface card. Similarly, if your worker nodes want to communicate with cluster, then they'll be using a network load balancer. So I hope you've understood. Let's go back and see if the stack is created or not yet. So once this worker nodes get created, all we do is we connect these worker nodes so that they can start interacting with cluster. As in we add this worker nodes to cluster. Then we'll launch a simple Nginx application on it. As you can see, the worker nodes are finally created. Let's go back to PowerShell. There's a command called get nodes. It basically lists out all the worker nodes that you've created. It says no resources found because we just created worker nodes. We have not connected them to cluster. So to do that, we use a Kubernetes object of type config map. So in my text editor, I have a file with .yml extension. As you can see, it's a Kubernetes object of type config map. Here you can see an ARN. Just now when we created a stack, ARN should have been created as well. So you can click on this and go for output. You'll find a ARN here, copy it and paste it here. I hope I've copied the right one, right? It ends with VA. Yeah. Save it and then store it in the same folder where you've stored your kubectl.exe file as well. Save and yes. Now, if we try this command again, it's again going to say no resources found because we just created a config map file. We didn't apply the configuration yet. For that, kubectl apply -f, your file name. Okay, let me check. Sorry for the mistake. That's the file name. It says config map created. Let me clear the window. Now to check if the configuration was done properly or not, kubectl get nodes. As you can see, nodes are properly created and they're attached to cluster properly. So like I said, we created a cluster, we created worker nodes and attached them to cluster. Now all we have to do is we have to launch a simple application on this cluster. So I'm going to launch a simple Nginx application here. For that I have two files. I have a Kubernetes object of type deployment. Using this I can launch an application on Kubernetes. So as you can see, it's of type deployment and file name is Nginx. You have something called pods. These are nothing but group of containers. Kubernetes runs containers on EC2 instances and it includes containers and specifications for how they should run and network and storage details and all. So these pods basically contain all that information. So I'm saying deploy two pods matching the template. And this is the application name, version, and this is the target port which I'll use when I'm trying to open application on web browser. Now suppose, what if node containing all these pods die? Well, you might lose the copy of your application, right? So to avoid that, you have a Kubernetes object of type service. So this Kubernetes object of type service is an abstraction which defines a logical set of pods running somewhere in your cluster. And all these clusters are provided with same functionality as the ones you've created in your deployment object. So I'm going to go ahead and save this file in the same folder where I've saved config map as well. So Nginx. Similarly, this as well. Save. Now let's go back to PowerShell. So as you can see, I have both Nginx documentation object and service object as well. Now we just save the files in the folder. We'll have to create an application. For that, we'll be using create command. Create -f and folder name. It says deployment Kubernetes object of type deployment is created. Now same for the service. That is created as well. So if you have to confirm that, then kubectl get svc or services wide format. So as I said, this is master Kubernetes, which we created earlier, the cluster. And this is the application which we just launched on cluster. So this is the external IP address that we are going to paste it in the browser to take a look at application. But before that, just go ahead and we'll see all the information about this Nginx application using describe command. svc Nginx. So as you can see, using describe command, when you use describe command, you get all the information about your application. You have type, which is load balancer. You have external IP address. You have target port using which you can open your application. So I'm going to copy this and paste it in my browser. Like I said, target port is 80. Well, there's some error. Give me a minute. Sorry guys, just give me a minute. Yeah. So as you can see, application is successfully launched. So like I said, using Kubernetes on AWS is fairly easy. Let's go through the steps which we went. First, we created a cluster. Before that, there were some prerequisites like IAM role to assign permissions to your Kubernetes cluster, and then VPCs and subnets on which your cluster can work on. Once we've done that, we created a cluster, then we created worker nodes and then to configure them so that they're attached to cluster successfully. Once your worker and cluster nodes are up and running, then we launched a simple Nginx application. So just don't stop here. Go ahead and try to create your own cluster and launch your own application on it. So this is it, guys. I hope the session was informative. Thank you.